One of the basic concepts that you'll come across in a career in engineering or mathematics is that of random numbers. And random numbers are used quite frequently, and a lot of computer programs will use random numbers. But what is a random number? And a random number, as generated in a computer program, is a mathematical algorithm, which is an equation that is used to generate these numbers. And these equations, these algorithms, are based on real life data. So someone collects data, makes a random number table, and then based on that table, they create the mathematical programs that they put into the computer programs to create random numbers. So it's important to understand the concept of how this works, because depending on the algorithm that is used is going to depend on the output of random numbers that you get. And random number generators are not truly random because it depends on how the programmer programmed the algorithms to create those random numbers. So that becomes an important concept, that they're not truly random. They're basically facsimiles of random numbers, because we can't always randomly pick numbers, so we have the computer do it for us. So for example, here I've created a random number generator table. And here's what I've used to create my numbers. I've got 6 Legos here, 6 different colors. Brown, lime, green, yellow, white, and red. They're all the exact same size, and they're in a bowl. I've got my special dice here. These are my Tootsie Roll dice. So each side of the dice, one is a T, a double O, a TS, IE, ROLL. So it's a Tootsie Roll dice. Then I've got my special cards here, and there's all between the values of 1. They're just special cards, all between the values. If you see that, let me put this over here in the camera, it would be helpful. So here's my special cards, and they're just numbers between 1 and 6. And there's 10 decks of cards, so to speak. So there's 60 cards in this deck, all numbered between 1 and 6. So there's a 1 in 10 possibility each time that you're going to come up with a particular number. So based on those 3 random number generators, I have created this random number table. So what I've done is, these are the letters of the alphabet, A through Z. See that? A through Z. The first column represents the random number generated by my special Tootsie Roll die over here. The second one is the one generated by my Lego generator. And the third one represents by my playing card generator. And as you can see, the patterns do not necessarily correlate with each other. They are different patterns. So this is the concept of algorithm. So if I were to create a mathematical model based on the first one, which is the Tootsie Roll die, I'm going to get a certain generation. If I go off the Lego one, it's going to be different. And if I go off my playing cards, it's going to be different. So what I've done here is I have circled when a unique value appears. So for example, the first one, of course, is always going to be unique. And in the second one, there's a real high probability that's going to be unique, and you'll see that. So on the die one, my second one, I hit unique on the second try. But look, on the third try, I've already got a repeat. So I don't hit the third unique one until the fourth try, and then the fifth. And I get down here at the letter H to get my 5th unique value, and I have to get way down here to letter P to get the final unique value. So you can see I'm getting more and more repeats as the process goes. Now we'll go over here to my Legos, and this one was really interesting because the first 5 draws of the Legos, I got different colors. And the probability of that happening is very, very small, that you're going to get unique every single time. So the first 5 were completely unique, and then I had some repeats, And what was interesting here is it's the exact same thing that repeated. So, I had green, red, yellow, brown, lime, and then I had 2 browns. So now by the time I get to the white, which correlates over here to age. So I hit all 6 unique values with my Legos at the exact same spot that I hit 5 for my dice. And that's, again, shows the difference of how you run the randomness. And it's completely random. But the fact that I had 3 of the same one within that 8, and the other 5 were completely different. Then finally over here to the cards. So the first 3 I had completely different. Then I had 2 4s. So now I'm getting repeats, but I'm getting the repeats, the exact same repeat. So I'm not getting a 4 and a 5 or a 5 and a 6. So I've got 3 of the same and then 1 of each. And then over here I get the 4th unique value, which is a 3. And then I get some repeats. And then my 5th unique value comes at I. So that's of the 3 generators, that's the latest point in time that I hit that 5th unique value. And then I have to go way down here to the letter P. Let me show you the letter P. So it's the exact same spot that I hit the 6th unique value for the die roll, that I hit the 6th unique value, which is 2, for the cards. So, and as you can see, like, for the 26 selections, I only had 2 2s. There's 1 there and 1 there. That's it. 2 2s. And again, there's an equal probability of selecting a 2 every single time. There's 10 2s in my deck of 60. So I got just as much chance of pulling up a 2 as I do any other number. But yet I did. Now, I can tell you right now, if I redid this exact experiment, then what would happen is I would get different results on there. So this is random number generation, and to get a concept of random number generations, try this yourself. So, or you could take one thing like some dice, and just roll the dice and do it 3 different times, and you'll see you will not get the same pattern of when they show up. And so you have to understand the concepts of random numbers and true randomness. So when we program a random number, we're making a mathematical equation based on this data. So we're using real data, and we're making a mathematical model based on that data. And the issue becomes that your data is not going to be the same every single time that you truly run random numbers, because they are truly random. So you will never, ever have the exact same data twice. So then it becomes, how robust of a data set do you need to get this random number to be random? If I make my equation based on just one data set, it's not going to be very random, because I only got one data set. Now, if I add all 3 of these data sets, okay, so I got 26 possibilities times 3, so I've got 77 different numbers, or 78 different numbers, I'm sorry. 78 different numbers if I do all 3. So if I now make my equation based on all 3 of these combined, I'm going to get a little more random. So then the issue becomes, to the programmer, how large of a sample do you need when you create your algorithms to truly simulate randomness? Do you need several hundred? Do you need several thousand? Do you need tens of thousands? Do you need millions of bits of data like this to create? And the more truly random you want to make your algorithms and your random numbers, the more data you have to have. So at some point in time, there's a balance between the true randomness of your algorithms and your equations in creating random numbers, and the amount of time invested in gathering the data on which to create those equations.